So tomorrow is the last day I'm grading anything from what we've done up to this entire semester. All right. So if you haven't taken a test yet, you probably need to sign up for office hours after school today, or sign up for office hours during tomorrow so that you guys can take a test, any test that you've missed. Any assignments that's missing, you guys need to make sure you get those caught up. So if you have an assignment missing, what you guys need to do is, how do you know what's missing, what's not missing? Actually, I got an email from somebody last night saying, Mr. Lee, what do I need to do to make up? I don't remember who it is, so it's one of you guys. This is me answering you. What do I need to do to make up any missing assignment? What do I need to do to grade on? Be specific. I love it. In the email, it says, be specific. I can't be more specific than this. Here. I can't be more specific than this. If you guys go to our homepage and you click on assignments, there we go. I click on the assignments. I'm going to put this in student view. Maybe. All right. If you put this in student view, you'll get a checklist of every assignment that we've done in this class up to now. All right. I would start, if you are behind in this class and you want to pass this class before this class ends, I would start with the most recent stuff and work myself backwards. So week 7, we are in week 7 right now. There's only one assignment that you guys haven't even started on yet. That'll be going on today. There were 3 things for week 6, really 2 main assignments. These 2 assignments are worth almost all the points. The telecommunication encoder decoder program and the final phone challenge. Those 2 assignments, probably say dash out of 4 for their grades. That means I haven't graded them yet. I will be grading these tomorrow. So hopefully those are done. There we go. I'm blurry. Everything on the screen is blurry. Is that better? Okay. All right, well, that's good to know. All right, so week 6, like I said, this is really all due by tomorrow. So there's a lot of people, you've put things off to the last minute. Guess what? It's the last minute because we're moving into a new unit. I don't want to have to go back and reteach everything in the old units. Remember, if you don't know how to do something, a lot of times within the assignment, there's video instruction inside of the assignment that can help you, like the decoder and the encoder programs. I record the video every day. And I put it in the module. So you just find whatever day you missed, you can watch the video for the class in there. So there's lots of ways to get caught up. And hold on, I got a lot of people coming in late here. Good morning, Kai. Good morning, Maria. Yeah, all these people are coming in late. You guys do know that class starts at 8:50 or 7:50, right? Not 8 o'clock. All right. So go back and look and see what you guys are missing. Start with the most recent. The reason why I say start with the most recent, remember, if you turn in 5 assignments, the district only counts the last 3 assignments on a standard. So yeah, your best bet would be start with the most recent work and get that done and work your way backwards. So if, for example, if you decided to start at week 2 and do the graphing challenge, you might see no difference to your grade. So make sure you guys are checking. Like I said, I'm grading all this stuff. When I'm done grading this stuff tomorrow, that's it. We're done. I'm not grading any more stuff on waves. It's all going to be astronomy from here on, which is a new standard, which if you've got a bad grade, but you've turned some stuff in, so you don't have the lowest grade possible. If you're not sitting here with an IE, if you're sitting here with an F that's maybe not like at a 1, can you get your grade up? Yeah, possibly, because we are hitting on new standards from here on out. So you do have 3 weeks to get things kind of caught up, but I do want you guys to make sure, I mean, let's try tonight to make a hard push to make sure you get caught up as much as you can. Does anybody have any questions as to what to do? And by the way, if you're a little confused by what's on the screen right here, it doesn't look like your screen. You might have your assignments that show by date. You need to click over to show by type, and it'll say week 7 assignment, week 6 assignments, quiz 1, week 5 assignments, week 4 assignments, week 3 assignments. That's how I put it into the grade book. So when you look in the grade book, I take everything from week 6, and that will be 1 grade in the grade book. So you may be passing right now, but if you didn't do the assignments from last week, those 2 big assignments last week, one we worked on in class, one you were supposed to do on your own. If you didn't do those last week, you could be taking a pretty nasty grade hit coming up. All right. Who's going to get their grade up? In chat, tell me right now, who's going to get their grade up between now and the end of the semester? Only 1 person? Okay, 2. Awesome. Well, I look forward to grading your guys' stuff tomorrow. Don't forget that if you guys do some of this stuff, to email me specifically, what did you do? So that not everything kind of pops up and hangs out in my face. You have to actually let me know. 2 people are gonna get the grades up, huh? All right. So yesterday, I was introducing the new topic to you guys, and I'm still kind of talking at the end, and I still got some things to kind of blow your guys' minds. We're moving into this new unit, which is called astronomy. And like I said, I asked you guys from the beginning, a little questionnaire at the beginning of the class to answer some simple astronomy questions. And quite frankly, a lot of them, a little shocking that you guys didn't know the answers, but not necessarily overly surprising. I'm going to click back to blurry here because I wanted to. I want to focus mainly on me talking right now for the video. There's a lot of things that you guys don't know, but the thing is that there's a lot of things that you do already know that have to deal with astronomy. And second, people are still coming in here. At this point, Mr. Tonzith, I'm going to make you a co-host. I'm not taking attendance anymore, so people are just going to have to log in via. They're going to have to just log in via learn.fwps.org. At some point, I have to start taking attendance. It's distracting. All right, so there's a lot of stuff that you guys already know about astronomy that you probably didn't know. One of the things is I asked you guys how old you were. You know, I think everybody in this class said that they were 17. Well, 17, what's that based on? 17 is based on how many times you have gone around the sun. So a year, 17 years is based on how many times the Earth goes around the sun. Or as, and we've been doing this longer than we've known about the sun, as the Greeks would have looked at it. The Greeks would have looked at it as how many times the sun went around the Earth. Okay. Now, the ancient Greeks, they didn't call this astronomy. In fact, they weren't really interested in astronomy at all. They were really kind of obsessed with the sky. Why were they so obsessed with the sky? Why do you think people, an ancient people, would be so obsessed? And I'm not just talking about the Greeks. I'm talking about most humans in most society, any kind of society, any kind of small culture, any little village. People were looking up at the night sky a whole lot, and the day sky for that matter. Why would people be so? Yeah. So I'm looking online here, and I see that Kai says navigation. Yeah. Imagine you are a Polynesian Pacific Islander. You live out in these islands. You're island hopping from island to island to island. How do you not get lost? Well, if you're in the middle of the ocean, what can you tell by looking at the sky to help you from not being lost? To keep track of what's going on. You say stars, but really it's two particular stars. One would be the sun. The sun tells us kind of the time of the day. But at nighttime, when the sun goes down, there's one particular star that we look at to figure out where we are. Anybody know what that star is? It's really aptly named. Nobody's got it? I could tell you right now, if I walked out this door and I looked up at about a 47-degree angle, I would see that star. And it's the only star in the night sky that doesn't move. What do I mean by the only star in the night sky that doesn't move? What do I mean by that? Well, if this globe, where the camera can see it, if this globe has all the stars on it and the Earth is rotating inside of that globe, that's kind of what we see in the night sky. It looks like there's a globe of stars. And if the Earth is rotating, it looks to our perspective like all these stars within 24 hours will rotate all the way around us. Except if you're standing right here and you're looking straight up. If you're looking straight up, anybody know what star is directly above us? Say that again, a little louder. The North Star. The North Star is actually, its name is Polaris. It's part of the constellation and the Ursa Minor is the name of the constellation, or if you guys might know it, the Little Dipper. It's on the tail of the handle of the Little Dipper. But that's where the North Star is. So if you could imagine this, if the North Star was directly above here, and here we are in Washington. If we're looking straight up in Washington, we're looking this way. In order to see the North Star, which way we're going to have to look? To the north. And if we're having to look to the north, we're having to look at an angle to the north. Now, if we go a little bit further south, that angle gets further and further down until you get to the equator, to which you're looking at the North Star right on the horizon. Well, we measure the angle of the North Star. You're going to get at the North Pole, that would be a 90-degree angle to the surface of the Earth. On the equator, that would be 0. So anywhere in between, you're going to get some sort of degrees. Seattle, we're looking at about a 47-degree angle. Anybody happen to know what the latitude of Seattle is? What latitude north are we in Seattle? Seattle area. Give you a big hint there.
Northwest.
But what's the latitude? What's the number latitude that we're at? We're north, what angle? .47. The angle in which we're looking at the North Star, is our latitude. The latitude of the North Pole is 90 degrees. You're looking at the North Star at a 90-degree angle. The further you go south, the more the angle goes down until you get to 0, which would be the equator. Okay, that's what latitude essentially, basically, that's what latitude is based on. So that means if you're out in the ocean, you look at the North Star, and they have this called an astrolabe, a little device that measures what angle you're looking at. That's how you figure out how far north or south you are. How far east or west you are, well, that's a little bit more complicated. You have to keep a watch, and for every 15 degrees you go, that watch is going to be off by an hour. So it's very important to have a working clock when you're on a ship. Now, grant you these days, we got a phone. Phone's going to tell us about where we are at any particular time. Or if your phone doesn't work because there's no cell phone towers, you have a GPS tracking devices. We have satellites. Once again, we talked yesterday about how important NASA is in giving us technology. One of those technologies that have only came about in like the last 15 years is GPS. You know, when you enter in your phone the map to bring you to your friend's house. Yeah, Mr. Tonsis and I back in the day, if we had to go to a friend's house, we had to listen to directions. We got lost a lot. We didn't have GPS on our phone. You know, strangely enough, I sit back and I think about that, Mr. Tonsis. I really didn't get lost that much. You know, we had like the old paper maps and we kind of looked at that as people drew a map to their house. I honestly did not get lost. It seems like after being so addicted to my phone and using my phone for directions, I feel like I'd get lost all the time, but I did fine back then.
Water in the mountains, and you know, like there's things that you can use as landmarks if you're looking.
Or that guy beside the road. Hey, dude, where's the place at? Well, you turn right at 7-Eleven. I'm like, okay, sweet. Now I got to just find that 7-Eleven. So yeah, it's another one of those benefits of NASA. All right, so we talked about that a year is dictated by the sun. And a day is dictated by how long it takes the Earth to kind of spin around and look at everything in the night sky. This is what they measure things by. Heck, they even were really good. I still do this today, to this day. I'll go out running and I'm like going, oh, sun's starting to set. How much time do I have? There's a thing that you can do with your hand. If you hold your hand up to the horizon and where the sun is, or where the hills are in the sun, that's about how far the sun will move in an hour. So you can kind of make a guesstimate as how far the sun's going, how much longer you have before you run out of daylight. Do you guys remember at the end of the class, how did we get months? It was a little gross. You guys remember how we got months? Was it the sun? Wasn't the stars? Was something else that almost sounds like month? In fact, the word month comes from this object. The moon. The moon, yeah. I heard Kai say it. I see that Elias wrote it on there. Eduardo, you said it too. Yeah, the moon. The moon goes around the Earth about every 27, 28 days. The gross part is how we were talking about how that was somehow or another evolutionarily tied to the woman's menstrual cycle. I explained to you guys how that worked. But yeah, about every 27 days, the moon goes around the Earth. Now, in order to get a calendar that always works, they had to kind of like bump it up to 30, 31 days to get 12 moons in a year. So our 12 months in a year. But basically a month, the word month actually comes from the moon, the word moon, moot. We should call it a moot, not a month. It comes from the word moon. Now, that explains years, months, days. What about weeks? What do we get? How many days are there in a week? 7 days in a week. Why do you think we break it down by 7 days? Well, the ancient Greeks and people even before the ancient Greeks, like I said, they were obsessed with looking at the night sky. It makes sense because, they didn't have street lights. They didn't have, when the sun went down, people either A, went to bed, or B, you went and stared at the night sky because there wasn't really too much else to do. Hard to do farming in the middle of the night, all right? And a lot of people very, very religiously watched what was moving in the sky. And what they noticed was this globe of stars, this celestial sphere, would rotate. All the stars seemed to be fixed on this object. They didn't know what it was. In fact, we've gone from culture to culture to culture, all kind of explaining, hey, what are stars? We don't know what stars are. I like the Lion King where they go, it's the spirits of gods, of great kings that have come and going up to the sky when they die. And then I would think that was Simba's. And then Timon was, I think that they're fireflies stuck in the sky, which Disney used in a different movie too. And then you have Pumbaa's like, I think it's great big balls of burning gas, billions of miles away from here. Funny thing that he was a little bit closer than the other two, but you got a good laugh in the movie because he was the warthog that farts a lot. Everything was gas with it. But they didn't know what these stars were. All they could see was that they seemed to be attached to something and they seemed to be going around the earth. Not the other way around where the earth is spinning. That wasn't in their concept. They thought that they were going around the earth. But they noticed that, like, for example, we talked about the sun, and the sun is in a different place every night. Throughout the year, the sun moves different from the stars. In fact, it's not just the sun, the moon. If you go out and look at the moon every night, if you look at where the moon is with respect to the stars behind it, every night the moon is going to be in a different place. So, I mean, the reason for that is if the walls of my classroom are the stars, well, the sun is going to be from the earth, the sun's going to be in a different place. Well, the same thing is with the moon. Here we go, that little pretend moon. The moon goes around the earth, so with the respect to the stars, the moon is always going to be in a different place. Okay. There were also 7 stars that weren't fixed, or I'm sorry, 5 more stars that weren't fixed. 5 more stars. There was 5 stars. All the other stars stayed in the same constellation, but there were 5 stars that they would notice that were always in a different place every night. And they would travel in a path across those zodiac signs. Anybody have a clue of what I'm getting at here? What were those 5 stars? Hint, they weren't stars at all. What would you go outside at night, look up at the sky and see, think it's a star, but it's not a star? Don't say satellites because we're talking about the ancient Greeks. They didn't have satellites back then. What do you think might be a star if you didn't know better, but looks like a star? Boom. Yeah. You guys ever do this when you were a kid? Starlight, star bright, first star I see tonight. I wish I may, I wish I might, I wish I get a pony tonight. You never got that dang pony, did you? Or whatever you asked for, the Lamborghini Countach or whatever. Yeah, you never got those. Probably because the first star that you see either in the afternoon, sometimes in the afternoon, sometimes in the late morning, the last star that you might see is the brightest star in the sky. Not a star at all. It's actually Venus, which is a planet. What planets? Here's a tricky one for you. What planets can you see with your eyes? Remembering that the ancient Greeks didn't have telescopes. It wasn't until Galileo used a telescope to look up at the night sky and see these things a little bit more close. We're talking about people before the Greeks, before Galileo. what planets could they see? What were those 5 stars that weren't connected? See if you guys can name them. Which ones could I take you guys out tonight if it was clear and point out? Okay, so somebody said the sun. Okay, technically the sun's a star, but what planets can we see with our eyes? Mars is one of them. Kai's got one of them. The moon is a satellite. Moon is technically a satellite, but we're going to just call the moon a moon for now. Mars is one. Elias, yeah, you're right. Mercury, Saturn, Kai, Mercury, which is really, really hard to see because it's so close to the sun. Jupiter, and the one I already mentioned, Venus. Mercury, Venus, well, we live on the Earth, Mars, Jupiter, and Saturn. We can't see Uranus, it's too far away. We can't see Neptune, it's too far away. And yes, that's how you say Uranus. I'm not going to back away from saying Uranus. We definitely can't see Pluto because it's really far away and really small, or any of those other planets that kind of fall into the Pluto category. So with our eyes, you can actually go out and see Mercury, Venus, Jupiter, Saturn. Which one did I miss? Mercury, Venus, Mars, Jupiter, and Saturn. Those 5 planets. Now, the ancient Greeks looked at those 5 planets plus the moon and the sun, and they said that those things were not attached to that sphere of stars. This is where I'm going to blow some minds here. You guys ready for this? They called those the 7 wonders. The Greek word for wanderers was planetai. How many did I just say? 7. What else does 7 mean? What's something else that maybe we've been talking about yesterday and today that 7 is significant to? Eduardo, you said it just a minute ago. 7. Something that relates to your life. Not years, not day, not months. There's 7. No? Weeks? How many days are in a week? And what's the first day of the week? Oh, the first day of the week is usually considered Sunday, named after one of those 7 wonders. After Sunday comes, or Moon Day. Monday means Moon Day. And what did you just say? Before Sunday comes, Saturn Day. Now you're probably sitting there wondering, okay, well, what is Tuesday, Wednesday, Thursday, and Friday? Well, this comes from Scandinavian, or what days of the week that we use in English are from Scandinavian words, from Scandinavian gods. So the Vikings looked up at the sky and they said they named it after their god. So Wednesday is named after a god that was one of the planets. So the Vikings did the same thing. They said the 7 wonders and they named it after each of those gods. For example, one of the Scandinavian, probably the only Scandinavian god, everybody knows who it is because Marvel makes movies about him. Who's the god with the hammer? Guess what day he is? Thursday. Yes, Thursday really is Thursday. So if you ever watch any of the Thor movies, you should watch them on a Thursday because that's his day. Okay. However, that's just English, right? That's our English translation. What if, I know I got some people who speak Spanish here. What if we go to Spanish? What is Monday in Spanish? Lunes, otherwise known as lunar or moon. Tuesday. What is Tuesday in Spanish? Somebody here's got to speak Spanish, right? Don't maybe have to look this up because my Spanish is not great. Tuesday? Nobody knows Spanish? Huh? Is it Martes? Did it come up? Okay, Kai, thank you, Kai. Yeah, Martes or Mars. Wednesday. We have to like look this up because there's always somebody that speaks Spanish in my class. What's going on, people? Miércoles, which is Mercury. What was that? Wednesday? Thursday. Jueves. Jueves for those English speaking. Thank you, Paula. All right, now we got Melinda and Paula. Paula, you're not chiming in. You guys can help me here. Miércoles was when Jueves, where are we on Thursday? Thursday is Jueves. That's Jupiter. Jueves. J-U Jupiter. Friday. Did I miss a day? What's Friday? They're typing, huh? What? Viernes. Viernes. Venus. And of course, we go back to Saturday, which is Sabado, which is Saturn. Or back to English, Saturn. So there's 7 wanderers, or as the Greeks call it, the 7 planetae, because they didn't know what planets were. 7 things in the sky that weren't fixed. So why do we have 7 days in a week? Because there were 7 things in the sky that weren't fixed. Maybe if there was another planet that we could see, we'd have 8 days of the week. Or if nobody ever found Mercury because it's too close to the sun, we would only have 6 days in a week. That's how it's all based on. The days of the week are just, it's 7 because there are 7 things not attached to that celestial sphere. And the Greek, like I said, the Greek called them planetae because they didn't know what planets were. That planetae just means wanderer in Greek. Later on, we defined what planets were, where we started seeing that planets, that the moon is something different from the other planets. The sun is definitely different from the other planets. So all this stuff, all our entire calendar really is all based on looking up at the night sky. And we've been doing this for years. We've gone through and we've been looking up at the night sky to try to figure things out. The whole concept of physics. And I get into this with Mr. Timulak, who's like the physics teacher here at TJ. I get into this with physics with Mr. Timulak, who's got the more important science, his class of physics or me with astronomy. And I said, well, if it wasn't for astronomy, there wouldn't be physics. Because when people like Galileo or Sir Isaac Newton or Einstein, for that matter, when they were coming up with these laws of physics, when they were figuring out things like gravity, were they looking at things that were happening on the Earth? No, they were looking up at the skies and making predictions based on what was happening. They would notice that planets like Jupiter and Saturn, as they moved around, they would slow down and speed up. That's how we found Neptune. We didn't know Neptune was out there. We weren't going to find it with a telescope because where do you aim the telescope? The night sky is huge, it's vast. The only reason we knew Neptune existed was because Saturn would slow down and speed up. A person who was doing physics observed the speed of Saturn slowing down and speeding up, saying, hey, there must be something else out there with a big mass that's slowing it down and speeding it up. And we're doing that now. I'm going to leave you guys with this. This is going to be the last thing I talk about, finally. I'm going to leave you guys with this. We've gotten really good at looking at things in outer space. A few years ago, 2006, we didn't have a definition of planet. We finally decided, the scientific community finally decided, hey, we need a definition of planet. Let's come up with a definition for planet. So they defined what a planet was and discovered that all the planets that we have, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, all fit into that definition wonderfully-ish. But Pluto didn't. Pluto acted more like a comet, a big ball of ice, than it did a planet. It didn't behave like all the other planets. So you've probably heard that Pluto's not a planet anymore. Does that mean Pluto blew up or flew away? No, it's still there. We sent a spacecraft. We took a picture of it, had a great big old heart on it. So everybody loves Pluto. Everybody loves Pluto, especially right here in America. You know why we love Pluto so much in America? It's the only planet we found. All the other planets were discovered in different countries, but we, here in America, back when when scientific discovery was important to us, that's when we discovered planet. It was a huge deal. When Pluto was discovered as a planet, they had parties in New York City, Pluto parties, a parade going down the main street of New York City saying, we discovered a planet, we discovered. Disney, this guy who makes cartoons, right? Named one of his characters after the planet. So if you've ever wondered, in the Disney cartoons, the dog, Pluto, was a planet named after the dog, a dog named after the planet. A dog was named after the planet. But it's not considered a planet anymore. And we've discovered that there's several other objects like Pluto out there. So if you want to call Pluto a planet, when you go to name the 9 planets, you better say Mercury, Venus, Earth, Mars, Jupiter, Mercury, Venus, Earth, Mars, Ceres, Jupiter, Saturn, Uranus, Neptune, Pluto, Maki, Haumea, Eris. Feel like I missed one. And Sedna. You better be able to say all those, plus probably some more, because what we're finding out there, we're after Pluto. In fact, Pluto is not even the largest planet of its kind. There are objects like Pluto that are bigger than Pluto, beyond Pluto. We know this for sure. A planet, a dwarf planet called Eris in our solar system. Here's where it gets a little weird. I'm waiting for this announcement any day for like the last 3 years. I've been waiting for this. We look out beyond Neptune. There's Neptune right there. Beyond Neptune, there's a bunch of icy debris. And all that icy debris is going around the sun, just like all the other planets, in a very, very predictable way. Except that as we're mapping this icy debris, we're discovering that some of that icy debris is not going the direction that it's supposed to be going. Imagine for just a moment that you're on a lake, on a nice calm day, so calm outside that there's no waves on the lake. The lake is perfectly calm. And it's been like the last couple of days, you know, with all the cottonwood, you guys seen the cottonwood out the last couple of days? Imagine all those cottonwood seeds floating on top of the lake. It'd be perfectly still, except that you see a line of cottonwood seeds moving across the lake. What assumption could you make if you saw a line of cottonwood seeds moving across a line in a lake? What assumption could you make? You didn't see what made the line, you just see them all moving. Thoughts? Sorry, I missed a full class. Could you make the assumption that something moved it? Maybe a fish, maybe a duck, maybe somebody went through in a motorboat. I don't know. But if you see all of the cottonwood moving across the lake, something would have moved it. What we're looking at in the outer parts of our solar system right now is that something, and it must be large, way, way, way out beyond Pluto, like way beyond Pluto, something very large has moved those ice chunks out of place, which means there's something large out there. I'm telling you guys right now, there's something out there in the outer parts of our solar system large enough to possibly be a planet. In your lifetime, it is very likely that we're going to discover that there is another planet in our own solar system. When I was your guys' age, the only planets that we knew of were the ones in our solar system. And the time from when I was your age to now, really since I started teaching, we've been looking at other stars and we've been able to identify that there are other planets. In fact, we've discovered over 400 planets outside of our solar system, which is really kind of neat. But that's what I'm going to talk about. So this class, as I transition to our next part, this class, what we're going to start doing is exploring the universe. We're going to start from the beginning. We're going to start by how our universe was created. Not going to be anything biblical. It's not going to have anything to do with religion. Okay. And I don't want to stuff anybody's religion. If you want your religion to have a moment of creation, that's fine. But I'm going to show you guys the evidence, the logical sequence of events that our universe started with. We're going to start that tomorrow, but for now, when I say tomorrow, I mean next class. So Thursday. Thursday is our next class. But for today, we need to get, make it so it's not blurry again. Today, we need to get to the point to where we have a common vocabulary, some words I want you guys to get to know. So if we go to today's assignment, I want you guys to open up this document. There we go. Notice that I have a vocabulary. It's blank right now. You guys are going to fill this in ultimately. What I want you guys to do is right here, it says, in the collaborative work, vocabulary of the universe. This is going to be super easy for you guys to do. And I'll give you guys a remainder of the period to get it done. So you should be able to open up this vocabulary of the universe document. I will put it in chat. There you go. I don't know why mine's taking so long to load, but I think I'm overloading my computer here. Okay, so basically what I'm going to want you guys to do is very simple. There are some words. Some of the words you guys probably already know. Some of you guys need to know. Some of the words going to be new to you. In terms, but make sure you guys keep this in with respect to what we're learning in this class, because sometimes words have more than one meaning. I want you guys to go through and define. This is really simple, guys. Just go to Google and type in definition of universe. I don't think my fingers work there. There we go. And there it is. There's your dictionary definition. Read the definition first, and then what I want you to do is just copy and paste the definition where it says universe. Then what I want you to do is go, and this is the one last thing, go to the Google images, keep the word definition of universe, and find a picture of what you think the universe actually is, and put it in there. I'm going to tell you guys right now, that is not a picture of the universe. That's something different. But yeah, make sure it matches that definition for universe. Then do it for astronomy, Big Bang, light spectra, galaxy, star, all perfect. And this is an assignment, easy assignment for you guys to get through. You just copying and pasting definitions and pictures. All right, I'm gonna give you guys the last part of Seraphel, probably not the Milky Way, but just the galaxy in general. I'm going to give you guys a remainder of the class. You guys can work independently on this. I'm going to go ahead and just mute myself. If you guys have any questions, feel free to ask, but this is what you guys should be working on for today. If you don't get done with it in class, it is going to be homework for tonight and tomorrow. Tomorrow is a synchronous day, so I can give you homework. Any questions? Any problems? All right. Good luck, boys and girls. One second here.